All right, today we're taking a look over the horizon at a technology that operates on the very edge of reality itself. We're talking about a revolution that feels like it's straight out of a sci-fi movie, but believe me, it's happening right now. This is the quantum revolution. So let's just start with a big question. What if we could solve the unsolvable? No, I mean problems so incredibly complex that even our most powerful, building-sized supercomputers would just give up. That is the incredible, almost unbelievable promise of quantum technology. So what even is quantum technology? Well, to get a handle on its power, we've got to dive into the super weird, almost magical rules that run the universe at the tiniest possible scale. This stuff is the secret sauce, the foundation for everything else we're about to talk about. Okay, first up is a concept called superposition. The easiest way to think about it is to picture a spinning coin. While it's spinning in the air, is it heads or is it tails? Well, in the quantum world, it's actually both at the same time. That right there is superposition. It's this wild ability for a quantum particle to hold a bunch of different values all at once, which lets a quantum computer explore millions of possibilities in a single instant. Next, we've got entanglement. This is the one Einstein famously called spooky action at a distance. So picture this. You've got two particles, and they're linked. They could be on opposite sides of the universe. If you measure one and see that it's spinning up, you instantly, and I mean instantly, know the other one is spinning down. It's this unbreakable, mysterious connection that's the key to creating perfectly secure communication. And finally, there's tunneling. This is basically the quantum world's version of walking through walls. It's where a particle can just pop through a solid barrier that, according to classical physics, it should never be able to cross. And because this effect is so sensitive to the tiniest little changes, it's the secret behind building sensors with a truly mind-blowing level of precision. So, how do we actually put these bizarre rules to work for us? Well, the most famous application, the one you've probably heard of, is quantum computing. And let me be clear, this isn't just about making a faster computer. Oh no, this is a completely new way of thinking about calculation that is going to redefine what's even possible. Okay, so here's the fundamental difference. The device you're watching this on right now, it runs on bits. And a bit is always simple. It's either a 0 or it's a 1. That's it. But a quantum bit, or a qubit, uses that superposition trick we talked about. So it can be a 0, a 1, and everything in between all at the exact same time. This is where the exponential power comes from, unlocking this massive new world of parallel processing. But you might be asking, why do we even need that kind of power? Well, because some problems are just too monstrously big for the computers we have. Take drug discovery. If you wanted to simulate just one complex molecule to find a new cure for a disease, that calculation could take a classical supercomputer longer than the age of the entire universe. It's just not feasible. And this is exactly where quantum computers step in. They could potentially simulate that molecule in a matter of hours, not eons. We're talking about designing new drugs and materials from the ground up. They could tackle Wall Street's most complicated financial puzzles to find the absolute best investment strategies. But there's always a flip side, right? This same incredible power could also be used to crack the encryption that keeps all of our digital lives safe and secure today. So, if quantum computers can break our current security, what's the solution? Well, what if we use quantum mechanics itself to fight back? This leads us to the idea of truly unbreakable communication systems. You know, the biggest problem with the internet today, its core weakness, is that a hacker can copy your data without leaving a single fingerprint. Your most private information could be intercepted and stolen, and you would probably never even know it happened. The answer to this is something called quantum key distribution, or QKD for short. It's brilliant, really. It uses those spooky entangled particles to create a secret key between two people. Because those particles are perfectly linked, the second a hacker tries to peek at the key, the very act of observing it, poof, the connection breaks. Both sides are instantly alerted that someone's listening in. The message is never, ever compromised. And look, this isn't just a cool idea on a whiteboard. It's really happening. China's Messiah satellite has already successfully beamed entangled particles over a distance of 1,200 kilometers. That proves that a global, completely unhackable quantum internet isn't just possible, it's on its way. Think about what this means for a second. The applications are absolutely world-changing. We're talking about financial transactions that are literally impossible to intercept. Sensitive government communications that can't be spied on, national defense systems that are fundamentally secure. This is way beyond just better cybersecurity. It's a whole new paradigm. But quantum tech doesn't just change how we compute and communicate. It actually changes how we see and measure the world around us with a level of accuracy that is honestly kind of mind-blowing. It's like giving us superpowers. So you get things like navigation systems for submarines that can work deep underwater without ever needing a GPS signal. Medical scanners so precise they could potentially spot a single cancerous cell. Geologists finding critical minerals and resources deep underground without having to drill a single hole. It's all powered by the incredible, almost unbelievable precision of quantum sensing. Okay, finally, let's talk about what we can build with all of this. Quantum technology is giving us the tools to design the materials of the future. And I mean literally designing them one atom at a time.
You see, for all of human history, finding new materials has been a really slow, messy process of just trial and error in a lab. You mix some stuff together, you heat it up, you hope for the best. With quantum simulation, we get to skip all that. We can model complex chemical reactions with perfect digital accuracy, designing revolutionary new materials right on a computer screen before we ever make them in the real world.
I mean, this just opens up a whole new universe for engineering. Imagine creating superconductors that could power a global energy grid with zero waste, batteries efficient enough to power a car for thousands of miles on a single charge, or even catalysts that could literally pull carbon right out of the atmosphere to fight climate change. We are talking about the fundamental building blocks for a new world. So, we've looked at 4 huge pillars of this quantum revolution. All right, let's pull all these pieces together and get a clear picture of the incredible future that's being built as we speak. Let's just break it down nice and simple. In computing, quantum gives us the power to solve impossible problems, like discovering new medicines. In communication, it promises truly unbreakable cybersecurity. In sensing, it's all about incredible precision for things like GPS-free navigation. And in materials, it lets us build a more efficient world with things like hyper-efficient energy grids. The main thing to remember here is that this isn't just another small upgrade. This isn't like going from the iPhone 13 to the iPhone 14. From our health, to our money, to our security, this technology is set to fundamentally reshape almost every single part of modern life.
And that really just leaves us with one last big thought. The quantum revolution, it's not some distant dream anymore. It's here. It's happening now. So the only real question left is, are we ready for the world it's about to create?